7. So again, review the product, quotient, power law. Don't have to review those too much. Just did those. Product means addition. Quotient means subtraction. Power law, bring the exponent down in front. Okay. We did this example in our lesson 6 just shortly. So just in terms of writing out the problem, so it's a combination. So we can practice. So here, see how the 3's are there? So we actually could do something like this. I could put the 3's up, right? Push them up as exponents. And so log base 2 of p cubed minus log base 2 of q cubed, right? And now watch. I can write this as log base 2 of p cubed over q cubed. Everybody with me? And then I know that if the top and bottom are cubed, we can write it like this. And then what can I do with that cube again? I can put it in front, okay, so that I have this, I can use this 8 again. So then it would be like that. We're just kind of working around. We already did this problem before. You don't have to do it that way, but now that we know the power rule, we did it this way. Here? Yeah, these are all Q's. Yeah, those are all Q's. Yep, sorry, these are all Q's here. That's why I write like that usually, but I didn't for some reason. Okay, so P over Q is 8, so then we're back to that answer we already know. Okay, P over Q is 8, so we can write 8. We know this is 3 log 2 of 2 cubed, so it's 3 times 3 for the 9 again, which we got earlier. Just did a little bit more with using our power rule. Right, you can use any way you want. Right, no, like this is just showing you what you can use the power rule for. Okay. Okay, so use logarithms to write 1/2 log A16 minus 1/3 log A8 is a single logarithm. Okay. So what would you want to do here? Here's okay. This is what I notice. We have some stuff in front that's bothering us. We don't know what A is. Okay, we're going to in a little bit. But if we want to write a single logarithm, we like to put these back in the log so that we can write them as single. Here's the nice thing about this. If I put this as an exponent, that's 16 to the 1/2, which means square root 16, right? So we know what that is. So that means we're going to go 16 to the 1/2 minus, and then same thing here. Log base A of 8 to the 1/3. The cool thing about this is square root of 16 is 2, cube root of 8 is 2. Or sorry, square root of 16 is 4, cube root of 8 is 2. They're nice whole numbers to my point. Okay, so that means those exponents actually go away. So log base A of 4 minus log base A of 2. And now we can use the quotient law. 4 over 2 is 2. Which I'll write it 4 over 2 so you see it. And so we're here as a single logarithm. Log base A of 2. Two over 1, no. Okay. Now, if A is 32, this is a tricky one. So if A is 32, then 32 to what power is 2? Well, the question is 32, 32 to the x is 2. So essentially, what power of 32? Well, obviously it's getting smaller, right? It's going to have to be a fraction, right? It's going to have to be 1/5. Okay, how do you get 1/5? Because 5th root of 32 is 2. Okay, now let's say you don't know that. That's okay. Then I'd write it like this. 32 is what? That 32 is going to be 2 to the 5th. We know that, right? If we go same base. So then we're going to have 2 to the 5x. Why is it 5x? Because there's already an x there. Okay? Equals 2 to the 1. So now they're the same base, so 5x equals 1. And you can see you divide by the 5, and you get 1/5 that way as well. What do you mean to think of 5? Yeah, if you don't know it's 1/5, then that's why you should do this. You should know that 32 can be written as a base of 2. That's what you should know. That's what I just did. 32 is 2 to the 5th. That you have to know. I think 1/5 is a little bit higher. Okay, a little bit harder. Okay, so I agree with that. Okay. Anything else? Okay, let's keep going here. Just one more page is all. Evaluate the following without using a calculator. Okay, there will be a non-calculator portion of your test, so count on it. So I said, don't get calculator dependent. Okay, 3 log x minus log x cubed. It's kind of silly, right?
And your class changed.
Well, if I put this up, it's the same thing. What's same minus same in math? 0. Nope, just 0. Well, it is. You guys are all right, but you're not knowing your rules. That's fine. Sure, if you want to write it. What's log of 1? 0. It still follows the same math rules, guys. Nope. Nope. Okay. Tags on Thursday, but thanks for trying. Log 5 squared. Log 2 squared. Okay, so that's going to be 25 and 4. Okay, so 25 and 4, I like that because if I put those together, 25 times 4 is 100. Remember, that's a 10 here. So 10 to what power is 100? 2. So this is a little bit messy right now as a quotient. So this one might be easier to break up and not write as a quotient. So write it as this and that. And then what I suggest doing is write them as a base of 3. We should all be comfortable in this class that 27 and 81 have a base of 3. We know that 27 is 3 cubed. We know that 81 is 3 to the 4th. So there's already numbers up there, so that means it's going to be 3 times 3. That's 9. And 16. So there's already a 3 here. 27 is 3 to the 3, so you multiply these two numbers. That's how the 9's there. 3 to the 4th, 81. There's already a 4 there, and that's tricky because it's already there, so it looks the same, but it's 4 times 4 is a 16. So now what I'm going to do is let's drop the 9, drop the 16. Why does that help us? Right, because the log 3 is nothing, or it's 1. 9 minus 16, negative 7. Okay, confused faces, ask questions. Can't read your mind. All right, 2 more examples then. All right, example 4 and 5. So if log 2 of x equals a, determine the expression for log 2 of 16 x squared. Okay, so, all right, so basically what they're saying is if I get a log 2 of x, that's equivalent to a. So let's break this down and see if we get any log 2 of x's. That's what it's telling you. Okay, so we want to break log 2 16x squared down and see what we get. So for example, I want log 2 of x's. So what I'm going to do is I want to break that 16 and the x squared apart. So how do I break those up? You could bring them down. I was going to do it separate, but I was thinking, in my mind, I'm going to do what I was thinking, and then we'll talk about what you're thinking. I was thinking about writing it like this. Breaking them up with addition, right? Because now we can bring it down. Okay, like Cash said, because that 2's there, now I can bring that down, so I have a log 2x. Do you guys see that?
Does it matter how you break it up?
4x and 4x. You could, but now the problem with putting the 4 like that is attached to that x when I want a singular x. So what you're saying would be okay, Aiden, but it wouldn't help you in this situation. Does that make sense? Because then you would have to worry about how do I get rid of the 4. Okay? So this comes down, guys. So then we're going to go, let's go ahead and write this as the base of 2 while we're at it. 2 to the 4th. So we see that that's going to be changed. Oh, that's not where I wanted, right? Okay. So we got 2 log 2 of x. Okay. Now, keyword, guys, in math it says expression, so you're not going to get an answer here. An expression means you're going to have a variable. Okay, you're going to have something that's not a complete answer. And that's okay. So what I'm saying is, this right here, log 2 of 2 with a 4, that's 4, plus 2a. That's the expression answer. Why is it 2a? Because log 2 of x is equivalent to a. That's the whole purpose of what we were doing. Okay, the 2's there, so 2a. This makes a 4. You're done. 4 plus 2a. Very, that's a diploma type of question. A lot of variables, a lot of stuff that looks harder than it is, and it's not too bad when you kind of get on track. Okay, any more questions? Last example. Or I shouldn't say any more. Any questions? We haven't asked one yet. All right, write the following expression as a single logarithm. So we're going to put this all together here. All right. All right, so let's go log BD. It's a minus and a minus. These are both on the bottom. Okay, so that's going to be over, to me, it's going to be E5, e to the 5th, and a squared. And then a to the 1/2's on the top, because it's a plus. Yeah, so I mean, there's not much I can do here other than simplify the what? The a's, yep. So by simplifying the a's, it's a 2 on the bottom. It's going to be 3/2, right? On the bottom. Because 2's on the bottom, 1/2's on top, so it's 1/2 minus 2, which is negative 3/2, which means 3/2 is on the bottom. Like that. That's it. Okay. All right.